Okay, so my video is on limiting reactants and percent yield. So to find which reactant is your limiting reactant, you have to convert the moles of both your reactants to one of your products. So for example, if we had 1 mole of A and 2 moles of B, we can then transfer moles of A to moles of C, which would be 1 mole of C from A, but B could make 2 moles of C, since they're all 1-to-1 ratios. So that means our limiting reactant in this one would be A. But then going to a real problem, we are given 1.85 moles of NaOH and 1 mole of CO2. For this one, to find our limiting reactant, we're going to convert it to moles of NaCO3. So to do that, we make T-charts. So we have 1.85 mole of NaOH, and that is equal to the 2 moles that were given in the equation. And at the end, we have 1 mole of Na2CO3. So that means, to complete the T-chart, we take 1.85 times 1, which is still 1.85, and divide by 2, which would equal 0.925 mole of Na2CO3. And then we have to find how many moles of the product we can make from 1 mole of CO2. So we are given 1 mole of CO2, and that is equal to the 1 mole it's given. So up here, this would just be like 1 mole. And that is also equal to the 1 mole of Na2CO3. And completing the T-chart, 1 times 1 is 1, divided by 1 is 1 mole of Na2CO3. So the limiting reactant is the one that makes the least amount of product. So in this case, that would be the 1.85 mole of NaOH. So NaOH is the limiting reactant. So that's how you find your limiting reactants. For the next problem, we're going to do a percent yield. So just a second. We no longer need all of this. Okay, so the most important thing about percent yield is it is actual over theoretical times 100 equals percent yield. So in the problem I found, you take CaCO3 yields CaO plus CO2. And in the problem, you are given 30 grams of CaCO3, and it produces 15 grams of CaO. So when it says it produces 15 grams of CaO, that is our actual number. So for this, we need to find what the theoretical yield is. So to do that, we take our 30 grams of CaCO3 and convert that to 1 mole. And the mass of CaCO3 is 100 grams approximately. And after we do the mole of CaCO3, we take 1 mole of that, like we're given up here, and convert it to the 1 mole of CaO. And then, since this was given to us in grams, we have to convert the 1 mole of CaO into grams too. And that is approximately 56 grams. So in the end, we found out that it is 16.8 grams of CaO. So we're going to write that up here. So we were given 16.8 for theoretical and 15 for actual. And therefore, using the equation up here, we take 15 divided by 16.8 times 100 will equal 89.28%.